the equation of the curve is given. We need to find the dy dx in terms of x and y. So when I look at it, I know it's implicit differentiation. So I get 3x squared plus 3y squared dy dx, and then you apply product rule. I'm going to take 2x as my u. So when I differentiate the y, I will get dy dx. And then I put my y, I differentiate the 2x, I'm going to get a 2 plus 0 equal to 0. So let's make dy dx as the subject. So you move over the terms which does not involve dy dx. So negative 2y minus 3x squared. I hope you can see it here. This one and this one. And the one that is attached to the dy dx is 2x and 3y squared. So you factorize and you can make the dy dx as the subject. So we will divide it with 3y squared plus 2x. It's a simple algebraic manipulation. Now the second part of the question says the tangent to the curve at the point where x equal to 0 and another tangent at the point where y equal to 0. Both comes from the curve. Where is your curve? Your curve is actually this one. Okay? And what are they doing? The two tangent line is going to intersect at the acute angle alpha. So when the two tangent line intersect, so let's try to imagine where is this. Just an illustration, it's not the exact one. So let's say this is negative 2, 0. The other one is 0, comma, minus 2. Simply draw a tangent line. I might be wrong here because mine is just an illustration. So let's say I have line 1 and line 2. So this is line 1, let's say we put this as line 2. When they are intersecting, this could be the alpha. I need to find what? I need to find the exact value of the tangent alpha now. So how do I find this? If this is my x-axis, I can see that the angle of, see, my tangent line is this one. Am I correct? This is L1. The L1, when it passes through the x-axis, you can see you actually have an angle here. So let's put this as theta 1. Similarly, the line, tangent line L2, when it makes an angle with the x-axis, I'm going to label this as theta 2. I am sure you have learned in IGCSE a concept called corresponding angle. If these two lines are parallel, then you can tell that these two angles are going to be same. So what I'm going to do, because the two tangent lines are intersecting, I can see that they are intersecting here. Exactly at this point, I'm going to create a line, horizontal line that is parallel to my x-axis, because I want to create the similar scenario like this so that I can match up my angle. Why am I doing this? I'll tell you in a while. So can you see that the line 1 with the x-axis, and similarly the line 1 with my horizontal line here, they should have the same angle, which is theta 1, which is theta 1. So can you see this? I hope you can see this. This is also theta 1 now. Okay, one more. I have my line 2 with x-axis. Again, my line 2 with the horizontal line. So these two lines, theta 2, these two angles, this theta 2 and this one, it's going to be the same. Can you see that? So I'm going to label this one as my theta 2. I hope you can see this. If you can't, you just pause and rewatch the video. So I am going to write an expression for my alpha now. I'm quite clear. I can see that my alpha is actually theta 1 minus theta 2. Because the question gave me an instruction to find the value of tangent alpha, I am going to write the tangent for the alpha like that, tangent alpha. So if I balance it, I'm going to get tangent theta 1 minus theta 2. At this point, you know that you can use compound angle and expand the formula. So what is that? Tangent theta 1 minus tangent theta 2 divided by 1 plus tangent theta 1 times by tangent theta 2. So all I have to do is find these tangent values, tangent theta 1 and tangent theta 2. But as per part 1, I only have dy dx. So what is the connection between dy dx and these angles? Okay, step 1. What does this derivative gives me? It gives me the slope at tangent line. Why is it so? What happens at a tangent line? Let's say this is your tangent line and you know that you actually can create a right angle triangle. If you create a tiny right angle triangle, let's say I park this as my theta 1. The opposite side here, of course, opposite over adjacent. And you know, as per trigo, tangent of theta 1, you can write the ratio, opposite over adjacent. But what is this opposite and adjacent? In relation to your gradient of a line, y equal to mx plus c. So this is gradient of your line. How do you get gradient of a line? It's actually rise over run. What is this rise over run? It is a change in your y divided by change in the x. So typically they are the same. Change in the y over change in the x. Because the two ratios are matching, I can tell the dy dx. What can I conclude? I can tell my dy dx at a given point, it's actually equal to the tangent. So that is the concept I am going to use to solve. So what is my point now? My point is 0, minus 2. At 0, minus 2, what is my dy dx? Okay, how do you do this? Take this and substitute into this. Okay, what would you get? Your x is 0. So that is giving me 4 minus 0 divided by 3 times by 4. So this is 1 over 3. And what is this 1 over 3? It's angle theta 1. So that is tangent theta 1. Now similarly, if you do for negative 2, 0, you're going to get your dy dx as, your x is negative 2 now. So that is negative 3, multiply with 4. And the bottom part is 2 times x is negative 2. So it's a 3, and this is tangent theta 2. You can substitute these values inside here now. So let's see what will I get for my tangent alpha. So 1 over 3 minus 3 divided by 1 plus 1 over 3 times by 3. A simple simplification will give me negative 8 over 3 divided by 2, which is negative 8 over 6. Simplifies to negative 4 over 3. You must understand, your question clearly says that you want the acute angle of alpha. Therefore, tangent alpha has to be 4 over 3. You have to remove the negative value.